Good evening, or good afternoon rather, and welcome to another episode of Talk on the Rocks. And this is the final and exciting conclusion of the main Hawaiian Island lecture, um, primarily dealing with Oahu, Kauai, and Ni'ihau. This is part 5. This originally started out as just a one-part series and blew up into 5, so apparently there was a lot of information to go over. So anyway, it is the 28th of September. It is about 85 degrees here in Maine, which is pretty unusual for this time of the year. We probably will not see 80s again until May. Once in a while we'll get a pop in April, but we go from heat to comfortable in August, September to the transition of cold in October to very cold from November to March. Those would really, you would consider those your winter months for sure. It can hammer snow in any one of those periods of times. So needless to say, it's nice to see it one last time, but we are going to start getting colder, and of course the days are getting much shorter. In fact, I'm sort of on a race against time, and hopefully the sun doesn't blast me out of this window. In October, you can't sit here in the afternoons because the sun now comes straight in when it's about to set. So anyway, on to the lecture. We have the we consider these the older of the main Hawaiian Islands because, they are older, but there's a significant change between, say, Molokai and Oahu. The Molokai volcano, yeah, it's dissected, but it is not to the degree that you would say Oahu and Kauai and Ni'ihau are. These are missing, large portions, in lots of cases, at least one side. Oahu's missing the east side of the Ko'olau and the west side of the Waianae. Kauai is missing parts of the northern side of the Kauai Shield volcano, as well as the eastern side, and probably parts of the southern side. Ni'ihau is probably missing, the complete eastern third of it. And when you look at the map here, you can see a sort of a conspicuous little line right here, or a drop off. My guess is that in its prime, this was probably extended out to here, and these are as far as the lava is piled and buried the Ni'ihau shield. And due to differences in subsidence rates, because one island got older or smaller, one island is much larger, you have sort of a relic boundary here, I guess you could say. Another thing with these volcanoes is they have vast amounts. Oahu, Kauai both have just massive amounts, in the sense of, what you consider large amounts of rejuvenated volcanism. So these islands allow us a great opportunity to really get good areas in good places of in good sections of rejuvenated volcanism. There is some on Ni'ihau. It's just not as extensive because obviously the island's not as big anymore and it's more eroded. But these two are just excellent study areas for rejuvenated volcanism, for a variety of reasons. So you've got Ko'olau here. This is the youngest. It's kind of shaped like that. You have the Waianae volcano here. It's missing the west side of this. Ko'olau's missing the eastern side. Here is the landslide. Here is the massive slump from the Waianae. So Waianae volcano might have been something like that. Maybe even curved out here. It was really, really big, we think. And this is, a portion of it that has disappeared and fell and collapsed onto the seafloor. It looks more gradual, so we call it a slump rather than a landslide. This seems more like a landslide. There is another volcano here, maybe even one here, or maybe this was one. But you can see again a weird sort of boundary here. Maybe this was as far out as Waianae had spread its lavas at one point out here. And same here. This one, I think this is called Kaena here. There might be another one here. And this is the boundary of the Waianae maybe. And then, of course, you have the Ko'olau here. These are interpreted as older shorelines, maybe at one point. Kauai had a shoreline that went out like this. I don't know. This area here seems to have really collapsed. And then, of course, Ni'ihau is something like this, and then you have Kauai Island here. But yeah, this is sort of the gist of it. We got landslide material here, here, and here. We think that it's still presently thought that this is one giant shield, and if it is, it's really big. It's an abnormally large shield. However, you know, there are some very strange tectonic and structural things that have revealed itself over the years. You know, the caldera doesn't behave like most calderas in the Hawaiian Islands. This one tends to be very resistant, whereas most others get eroded quickly. There's a fault boundary back here. You can almost kind of see it right here, almost as if there's, you know, maybe two different volcanoes. And then, of course, it all gets weird under here, too, in the Lihue Basin. So the jury's, I don't know. We still stick with it, but there could be some changes. Ni'ihau's pretty much consisted of one volcano, and you also have a little island over here. That was its own volcano. Whether or not these were very big, hard to say. Maybe Ni'ihau was something like that at one time. I don't know. All right, Oahu. This is a little bit busier of a map than I would have wanted to make, but, well, there it is. Anyway, so this really is all of Oahu's history kind of in a nutshell. So Oahu really consists of three volcanoes, kind of is off the map. I kind of just referenced to it. I won't talk much about it. Don't really know that much about it anyway. Then you have the Waianae volcano, which is right here. And again, this comes out and was probably something like this. And then, of course, we have the Ko'olau volcano, the youngest, which is, you know, something like this with its huge landslide over here and the whole northeastern side of it missing. Oahu, it's sort of, I want to use the word stitched together right here with the plateau here where Wahi was and Schofield Barracks. For the most part, the Waianae lavas are overlain and overlapped by Ko'olau lavas, so this is obviously the younger. And then you have a drowned river basin here, and of course you have Waikiki here, the world famous Diamond Head here, Sandy's, the east side, the North Shore, my favorite spot. And then, of course, you have the western volcano, the Waianae volcano, which, you know, the top of it's here, and you can see that obviously about half of this is gone. And of course, the west side towns have a tendency to occupy the valleys, and the caldera, which occupied right here, is nice and hollowed out, so it makes a nice flat area for the town to sit in. And the same thing over here in Oahu, Ko'olau, right in here is what we think the caldera of the Ko'olau, and it makes a nice area for Kailua and Kaneohe, which both open up and have beautiful bays. So, let's go through the stages here. The Ko'olau volcano is in rejuvenation dormancy, we think. We classify that because the area between rejuvenated eruptions is much longer than the time between the last eruption and today. So, hence, it hasn't crossed the threshold to where we can say, all right, it has now gone past the longest period that it's erupted. In between intervals, then we might say it might be extinct. Hasn't happened yet, not by a long shot. It was around probably about 3.4 million above sea level by about 3.1 or 3. The last known eruption is rejuvenated lavas and eruptive events. You know, we think right now is the last one was about 40,000 years ago. And suspicious areas are here and here. This one, I don't think this one's a little bit older than that, but these are the areas where we got our last eruptions on Oahu. The Cocoa Rift here, used to be a cinder cone here that they kind of mined out, but this sort of made the sandy beach area. In the lava flows, we had one up here that was on top of Tantalus that yielded a fairly young age. I think these are the youngest over here. And it dropped down and went into Manoa. And I believe it went right out down through here too. You can see it underwater, or at least a rejuvenated flow. And then you have near the muck where the Sea Life Park is, there's a nice young spatter cone behind that. So any one of these are candidates for the last eruption, but it's probably this. The Waianae volcano, however, and it must also be said that the Kauai volcano did not go through a post-shield stage. In other words, geochemically, it just produced nothing but tholeiitic lavas, and we have reasons for that, which I went over in the first lecture. I may touch upon that again, but it may have something to do with the deep magma source injection that basically changed the chemistry of the replenished the deep reservoir and also changed the geochemistry. Now the Waianae volcano did go through the three stages. It went through the pre-shield, pre-shield, shield, post-shield, and we think that this was once considered rejuvenated. I don't know. That's still sort of suspicious. And so for the most part, the Waianae volcano has not had an eruption that we think in over 2.5 million years. So that's a pretty good candidate to be dead. It's gone through uplifts and massive slumps and what have you. So I don't think anything under this is going to be tripped. Maybe in the end, I don't know. I mean, you look at Ni'ihau; it's much more eroded and older, and it has eruptive, late rejuvenated stage eruptions, but it didn't have a gap like this one did. So, anyways, Waianae volcano, it's most likely extinction, 4,009 feet. The age is about 4.45 million. It kind of started its life. It became above sea level by about 4.2 to 4.0. Last known eruption is a post shield, a very, very silica rich post shield right here in the Kolikoli Pass. And the last eruptive events are in the order now of 2.5 million because we have not seen anything that we know of since then. So that's Oahu in a nutshell. This is a geologic map of Oahu. I didn't really want to go into one with huge detail. It'd be nice to sit and, you could block off all these. But the gist of it is anything that is in tan is alluvial. In other words, it's calcareous. It's been derived by offshore reefs or just detrital debris, sand, could be mudslide material from the volcanoes. But in any case, it's erosional material. Anything in the dark green is Waianae basalt. Different stages. This is probably main. This is post-shield. The Kauai only has tholeiitic stage, so that's what you see in here. The Kauai has numerous dikes, though. Dike swarms, same with the Waianae. You can see that's how we define the rift zones. We know that this one kind of went like this, and this one kind of went like this. The caldera is in here. Over here, it's somewhere in here. It's not listed out on here. And these are sort of the times which you can't see. I apologize for that. A little bit blurry, but what it basically is telling us is that these are magnetic reversals and polarity reversals, which again are not clear in this. But it essentially we record magnetic reversals. I think in the Kauai, if I'm not mistaken, there is a shift recorded between these two. I can't remember, but there is a shift, and that's one of the ways we can time when this thing was really active, is polarity shift. So my guess is that this is Kauai here, this is rejuvenated here, and this is Waianae here, and maybe it's between these. The Kauai basalt record a shift in here, and I think the shift is white. So very interesting stuff. Waianae, I think, also records a shift, but it's not quite as well documented in its lavas as it is in the Kauai's. Kauai's, it's just the whole shield is just basically tholeiitic, so it just had a very long period of time of tholeiitic eruptions, whereas Waianae, it's not quite as active as that long. All right, so a more simplified map showing the calderas and the various lava types. All these little purple things or samples have been taken. I'm just going to I'm going to just kind of reiterate what I said last time. So in the Waianae, you have your probably shield here. You've got alluvium from the colluvium. I always get those two mixed up. It's just basically material that's eroded off the mountains. It's dirt that's in clays that are eroded off the mountains that are not. They're no longer on the mountain. They're on the mountain, but they've been removed and they've piled up at the base. So they fill up the basins. The darker is most likely upper level late stage, and then you have post shields probably here in the purple. These are some of the later ones. We also have a very weird one over here on the Koli Koli Pass, yeah, right here. Actually, it's right here. Uh, the Oahu, you have the huge shield building mass of the Ko'olau basalts. You have the caldera here, and this is caldera lava filling. This is uh, very thick lava flows that ended up filling up the caldera. The purple is is rejuvenated. So you can see this is an extensive amount of rejuvenated volcanism. And of course, the alluvial is still represented here. These reds are dike swarms that you can find these all along the rifts. And of course, over here we also have the Lualele caldera of the Waianae volcano, and they're almost appropriately about the same size. The calderas can vary, but these two are fairly large and fairly uniform in size. All right, Ko'olau alkali silica diagrams. As I said, the Ko'olau Range has no post-shield volcanism. So, for the most part, for its entire life prior to going into rejuvenation stage volcanism, the Ko'olau volcano only erupted tholiites, and that is seen right here. This is again our old classic standard bar, which we measure things by, the Mauna Loa and Kilauea tholiites, right here they're right here in the middle of their lives and cranking. Well, Ko'olau has very similar geochemistry. Boom, right there, and it stayed there. It did not evolve like it should have. For one reason or another, the tholiitic lava stayed tholiitic and stayed without contamination, and did not differentiate to the point where it began to start moving this way. However, the rejuvenated lavas plot all over the place. So you got some that are here that you would consider alkalic, classic post-shield chemistry. But then you just get stuff all over the place, and you get really, really deep silica undersaturated rocks. I mean, these are getting very, very undersaturated. So you have a whole new base of nephelines or nephilites or melolites, and these are silica undersaturated minerals that are generally found in very deep lavas. And so that's sort of the key of understanding the rejuvenated volcanism, is that you essentially you have a gap in time, and then boom, you just go over into a completely different area. And so something significant happened here in order to do this, and then to drive it, such a deep source, to pull up really heavy silica undersaturated stuff is very interesting. And some of the most famous flows, the one that University of Hawaii is located on, is a melolite flow. It's huge, thick. I think it's something like 42 feet thick or something. Big, thick, fat flow. Excellent blue rock. They used it to build a lot of structures. And now the parking structures there, part of it. And then there's a big sheer cliff where you have all the fields and stuff down in there, where they play ball and everything. Baseball, football, basketball. The arenas down in there. But you find these all over eastern and southern Oahu, these very, very silica undersaturated rocks, and they these make up the rejuvenated volcanism of Oahu. And you can see they are two very, very different geochemically different magmas, for sure. It's tough to really try to explain all of these, but we know that some of this is mixed with some other stuff, which is mixed with some other stuff to make up this. And I went over that back quite a while ago in the different lectures, that you take a little bit of depleted, you take a very little bit of the ocean crust, and then you add the walls of the throat, per se, of the tholiitic portion of the plume, and you mix those and you decompress them a little bit, and guess what? You start to get something that pops up over here. And because Ko'olau was a very vigorous volcano and really tapped deep, and it had a really good reduced plume put into it, of very, very deep primordial material, it allowed it to when it finally mixed with other stuff, it really allowed the silica content to be very undersaturated because it was so deep and so primary. Um, so yeah, it's a very intriguing volcano. Here are the ages of the Ko'olau volcano. So here we have the shield building stage, and it's what, 3 to 2 to, man, that is a long time to build a shield stage. So I mean, that is, that's a good million years of shield building stage. And for the most part, the geochemistry of the remained tholeiitic throughout its first million years or so. It did not differentiate or become contaminated and start producing post shields. However, we do have a gap of time from about 1.7 to about 1.2, so about 500,000 years, where the volcano remained fairly quiet, and then bang, we go up into the Honolulu volcanics. And I mean, they go from about 1.25 million all the way out to about 40,000 years ago. And this is sort of a blow up of closer ones that's sort of down here, because we have dated so many of them. And it would be only a fool who considered and say that island is dead. These have gone on for a very long time. The gaps in time are much larger than the period of quiescence that we have now. So my guess is that we are going to see future eruptions on Oahu of rejuvenated volcanism. And if one was to happen today, it would be either right around the Makapu'u area, maybe Kaneohe, maybe Kailua, slightly offshore, or Sandy Beach area, or Hawaii Kai, Diamond Head. Could even go to Salt Lake, but somewhere in southeast Oahu, south or east Oahu is where that's going to be. So, what is the mechanism for? Let's talk about the rejuvenated volcanism for just a bit. Something has got to be triggering, a radical shift to get, get 500,000 years of quiet, and then boom, everything lights right back up again, and has been going very consistent for a long time. So what we think is one island will actually influence another, and the gist of it is that, so right now, Kilauea, Mauna Loa are just rapidly building. Mauna Loa is hitting the late main shield stage. Kilauea is in the right in the main shield stage, the center of it. So it's absolutely just going nuts. And as these volcanoes build, they are huge and they are heavy. And what happens is you will begin to make almost like a flexural ring, like if you put a bowling ball in a bed. It would go down in the center, and there would actually be a ring around it. And depending on the material and how flexing it is and how rigid it is and whatever, the ring might be further away than right next to the ball, or it might be right next to it. Well, in this case, because of the way that the islands are, it tends to be out about, I think, God, what is it? It's 200 miles, 100 miles, 100 miles, I believe. In any case, what happens is, it may even be shorter than that. I'm not exact. I'm just trying to think. It's the distance of the ring. Distance of the ring. I don't remember. It's somewhere between 50 and 150, or it could be 50 to 200. But somewhere there's a moat, and then there's a ring that goes around the island of upward flex because of the pressing down of the other, the bigger island. Big island is getting bigger, and it is pressing down further and further. So no matter what, somewhere down, if there's a fulcrum, Maui right now we think is the fulcrum, and Maui is actually being tilted towards the big island, and we can see that because Haleakala is increasingly leaning towards its very unstable side, which is probably going to collapse. And if I was going to put my finger on the most dangerous place in Hawaii, aside from Kilauea, it would be Haleakala's south and east side. The whole thing is tilting. So if something is tilting and pressing down in one place, it must be lifting and relieving pressure someplace else. And as that turns out, this probably happened. Between, it could be Maui, and it could be the Big Island. Maui might be more responsible for flexing Kauai, whereas the Big Island might be more responsible for flexing Oahu, but it's somewhere along the round. The Big Island has lifted a Kauai volcano, and it has created an area and allow once you decompress this all this stuff down here kind of gets dragged, and so what happens is there's a couple of areas where you flex, and the deeper one, once you start to, this is all kept under wraps by the pressure. As it slowly drifted, it's, the weight of the island keeps it, keeps everything at a certain, well, not a certain temperature, but it's much harder for it to melt because of the pressure. Just like the inner core of the Earth is hotter, but it's solid because the pressure just it's the pressure beats is stronger than the heat. The heat will not, but you move from the from the inner core to the outer core, it becomes liquid because the pressure is not as much, but yet the heat's fairly similar. It's the same idea here. What's going on is the Big Island pressed down one place, it began to lift up underneath Oahu, and Oahu began to initiate I apologize, this is driving me nuts. Oahu began to, the base of Oahu down underneath the oceanosphere began to melt. And as it melted, it became unstable, it became buoyant, and began to start to punch up through. So underneath the lithosphere and the oceanosphere also had an area that lifts too. And so you induce another area of melting. So you actually have a couple of zones of melting. And then they start to mix, and you also have residual stuff from here that's all mixed in with this. All these three things mix, boom, you get rejuvenated volcanism, and the rejuvenated volcanism does not follow any of the old zones or anything like that because this mountain is locked solid. So things have a tendency to go around. Probably there's a big, deep a big shallow magma chamber that's solidified, very difficult to punch through. So it makes sense that the lavas will divert around the center of. There's very few. I can't think of that many eruptions right in the center of the caldera, which was theoretically where the magma chamber would have solidified, and we do know it did because you actually weigh more in Kailua than you do in Waikiki, and that's because there's a big, giant, solid magmatic body of iron-rich magmatic body underneath there that's solidified. So the lavas come up, they divert, they go around, and they have a tendency to be offshore of Kailua. They have a tendency to be south of Kailua. They even have a tendency to be a little bit north of it, and they certainly are west of it. But they are not right in the caldera because it probably cannot. It's very difficult. The crust or the magma chamber is very dense and it's solid, and it's very tough to go through a big pile of iron-rich rock. All right, so to further confuse you with that, this is the distance from Kilauea versus stage and time of the rejuvenated volcanism. So as I said, you have Kilauea, Mauna Kea, Kohala here, and then you have uplift here. Oh, it's 300 kilometers. Okay, good. I do have that. Over here, you have the Maui Massif and Maui Nui, and then you have a massive amount of rejuvenated volcanism on Kauai. And the thing to notice, these are at the same times. The distance is almost the same. It's the same thing here. You have this mount here. This is building up and pressing down. You are flexing Kauai, and Kauai went through a very long period of rejuvenated volcanism in relation to this. And it is the same thing here. As these grew and became much larger, they lifted Oahu, and you have an extended period of rejuvenated volcanism. And it even contributed to some of it here probably, because you have a little bit here on East Molokai, and West Maui there's a small eruption. So it may even, so as I said, Maui is actually tilting towards the Big Island like a seesaw, so maybe that was in relation to some of this. But it looks to me like the mountains needed to be slightly bigger because you initiate a lot more here. As they get younger, you're not quite yeah, if you get down here, the heavier it got, then you started to see something go on here. But it was the main building stage here, and plus you have to have hulalai in here. And then as they got bigger, and it got it got big enough, it actually began to start to tilt East Molokai and Maui, the Maui Nui, towards it. And so later, a little bit later, you start to see rejuvenated volcanism show up on them too. So here, at first, it really seems to be starting on Kauai, but then you start to see some activity here about 2 million years. And it probably has something to do with the addition. These were two very large volcanoes, and then you add two more. And I think that, so you can say that these two are related to this, these two are related to that, these are related to this. The deeper, once they got bigger, they're related to that. So, math doesn't totally work out, because if that's the case, well, let's see. These would have done this. These are younger. So really, it should have been the other way. But for one reason or another, we're seeing Ni'ihau rejuvenated volcanism show up later than Kauai. And again, the rejuvenated volcanism is by no means a very set protocol. It is all over the place. We just look for small things, or anything if you can, to try and see if we can get some sort of correlation. And for the weight and the decompressional melting, it seems to agree at least a little bit here and here, that these two, you can make a case for that. But is it exact? We don't know. Rejuvenated volcanism is very complex. If you understand that, you understand it all. Because, as I said, it has to deal with magmatic mixing, different chambers, different depths, different flexural rates. How big was this volcano? How big was that volcano? What was the original composition? What was the deep source? I mean, there is just so many different ores in the water, so to speak, in making this sort of thing. So if we can make any sort of correlations that are it's a start. So that's pretty much where I'm going to go with that. All right, here is a picture of Oahu on a big south swell day. I would say that this could be 3 to 5 maybe, 2 to 4, 3 to 5, I don't know. But judging by the watercolor, it's a fresh swell. Probably early in the season, because it's churned up the water, and it you can see the path right here. This is Publix, and it just grinds along here. Now, when it gets big, real big, it starts breaking out here, and I've seen it when it's lit. Things are lit up out here. In fact, I caught one of the best waves in my life that was somewhere out here, and I just came through this bowl, and man, it was a 6-foot just bombing, in and like, felt like you were in Indonesia, man. I will never forget that wave. That's just one of, Waikiki, you can laugh at it all you want. And let me tell you, Hurricane John, like 20 years ago, I had unbelievable, absolute macking bomb in and out there. One of the best barrels of my life on one of those out of probably Paradise or something, but it was like 6 to 8 feet. Just the hurricane was like within 200 miles. And I've had epic rides, it's so many of these waves. But yeah, when you surf the North Shore as your primary battleground, the town always takes a second seat. But it does have its moments, and you know what? It's a wave. There's a lot of waves. If you want to go explore, that's why I put this picture up. This is called Sleepy's to Kunas, and oh, that's right. This is Kunas is breaking. Publix is over here. So this is a big day. Interesting. I did not catch that. Yeah, so this is a fairly big day. You got a couple. It's not big enough where it's starting to pop and peak out here, but this is a pretty decent size. And if you're outside here, that's telling me that that Kunas is cracking. And Kunas is a very it's not a very it doesn't break very often. And it's a left that just hammers right through the stays dormant for 95% of the time, and then you get that right swell and it just comes alive. So there's Kunas here, you got your walls here, you got Publix here, you got something that's not named here, then you've got castles out here. How's that go? Pops, not Pops. Old Man's, No Man's, sugar, rice bowls. And then some are up in here. Rice bowls is another fantastic crazy wave. Tongs, then a very, very rarely surfed wave out here called zeros, which only breaks on the biggest and badass swells. Right. If you find yourself surfing zeros, you are like you want it. It's absolutely hair raising out there. I've only seen it break a few times, and I was lucky enough to go back out there in 1996, I think it was. Might have been 96, 98, and just helicopters and we all right, and just at, as big as the South Shore could ever want. Then you get over here winches, get the name of that, suies, and then sleepies, which I don't mention those names. Those are secret spots, damn it. Anyway, this is just Oahu. This is Diamond Head, about 500,000-year-old tuff cone. Erupted, sort of built this peninsula up, I'm sure, with the fallout and the ash and everything like this. Is Kapolei Park. Yeah, it's taller on this side because the trade winds we think were blowing it, similar at the time this erupted, so ash piled up more on this side. The Nu'uanu Poly. This is Waimanalo, looking back against the Poly, which faces east. Is if you go over from Waikiki to the east side, you go through a couple tunnels and then you drop, and there's just this giant, cliff that's like 1,000 feet high. Some places even higher, and probably about I don't know, 10-15 miles long. Anyway, it's all over southeast Oahu. And we always thought it was sort of the boundary of the caldera, but it might be a little bit more precarious than that, because we also think that the giant landslide of eastern Oahu might have also helped cut back. So the Poly could be a landslide scar that's been modified. It could be somewhat, the caldera. It's probably a little bit of both. But in any case, once you get out of the Kauai caldera, the rocks get very, they're not altered anymore. They haven't been altered by steam or weakened, so they become they're back to being very strong iron-rich lava rocks, and so they don't erode as easy. So you have wherever that Poly is basically it's sort of a retracted boundary of where rocks that were weakened due to landslides or hydration or whatever gases, and somewhere. It represents an older boundary that was out more eastward that is eroded back, but that is sort of a boundary made by two rocks that are altered and soft, as opposed to rocks that are, in situ, have not been, altered by steam and gas and water, and they remain very hard. Oh, and of course when it rains, looks like tinsel on trees. The waterfalls are, they are just unbelievable. This is more of a better picture of it. I was actually this picture that I just showed you here is probably somewhere behind me, but this is an epic picture of the Ko'olau, the Nu'uanu Poly, and you can see it's a very abrupt drop, and then it slowly goes back, and these are all individual lavas that go out to the southwest. One guy, I don't know exactly where this is, but I don't think I've ever stood there before. That's a great place to stand, though. Yeah, you can hike out. There's numerous trails that come from the southwest side to the northeast side, and you can pop out anywhere in here. Some of them are absolutely hair-raising. I'm sure there's some lunatics that have done the whole ridge before, but it's not easy hiking. It's funny, tropics can be just as demanding as any other place you'll go in the world, and the Ko'olaus are no exception. They can be terrifying in places. All right, Waianae Mountain. So here's the Waianae. This is sort of the alkali silica diagram of the Waianae Mountain, the Waianae volcano rather. And as you can see, the Waianae the Waianae is a great volcano to study because it basically gives you everything. You have our Mauna Loa and Kilauea rocks here. For our tholeiitic standards, you have the basically the shield stage of the Waianae is right here. You have late shield stage of the Waianae volcano here. You have the post-shield stage here, and then you have another post-shield stage here, and then of course you have this trachei flow way the hell out here, and this is just a very bizarre. It's almost like over on you have that on the West Maui, and you also have it one place of it on the Big Island in Pu'uawa. These very silica rich flows that this very they're differentiated and they're much different than anything else. But you can see there was a trend of it heading that way. So this is just probably the end point here. But so the Waianae volcano shows a very wide range of lavas, and it has all the things you could want. Again, your very deep tholeietics, your shields, your post shields right here. The one thing it doesn't have rejuvenated volcanics. So if they did, they would be somewhere probably over in here. Waianae volcanic ages. Again, they really follow in nice, and this is a very just well-behaved volcano. If you would, you want to, if you really wanted to if there is a volcano that follows a very nice trend, this would be it. So you got your deeper shields here, then you've got your post shields, shield, late shield, post shields down here, and you can see that the early shields between 4 and 3.5, and then you went into your your later shields, which go from 3.5 to about 2.8. Then you have your post shields that are from about 3 to 3 to about 2.8, and then 2.8 to about 2.7 or so, and there's a couple that are maybe around 2.5. So as you can see, this volcano is very straightforward, and there aren't too many large gaps. It sort of just evolved over time. There's some small gaps, but for the most part, they're not very big. This one just sort of geochemically, it sort of evolved more or less synchronous. It didn't really have large gaps. What this is down here, that is a very interesting. I do not know what that is. Lualele, so that would be an older one. Why would you have one? I'm sure that comes up with great scrutiny. Mount Ka'ala. I was fortunate enough to go on a trip to the top of Mount Ka'ala. Not many people ever get it. It's full-on lockdown, heavy-duty military. You can't just go waltzing up there. It's all fenced in. It's a very flat. I think it's rhyodacite site, lava flow that is incredibly resistant. So resistant, there's even a bog up there, and it has all these unique species. And a few interesting key things about this place. One, there really was a gondola that went up. It went up from the east side. Here is the summit tower. I couldn't believe it myself. I'd heard rumors. And there it is. And then there's another tower down. So it was almost like a very simplified tram that you could come up. And I think this was the wheel right here. And you came up, and there was a tower, one or two towers down here. It was, for the most part, pretty steep drop. So you drove up down here. There's a road that came up here. You went to the base, and then you rode this thing up, and then this was the summit tower. And I'm not sure if you got off here and walked it. You might have, or there was actually another tower a little bit further up. I think there might have been. I can't remember. But in any case, actually, I remember this just being the only thing I could find of it. So here's a sort of a ridge of the Waianae volcano. This is all Ko'olau over here. It's Pearl Harbor down here. Yeah, I forget what the name of this town is. Schofield here. Mililani. Yeah, Mililani. So yeah, about 4,000 feet up. It does get cold enough. I've talked to guys. They said they have seen ice out here before. So it's not unheard of. They've had some very strange weather up there. So it's a very cool place. So this is the summit of the Waianae volcano. This is the road up. There was talk when they were trying to build this that this road might not have been able to be completed There were engineers that doubted whether it could be done, but after, I guess, going through a couple of different contractors, they were able to do it. This does nothing. This road is incredibly steep, incredibly narrow, and we had to drive, auger rigs and direct push rigs and support vehicles up here. So it was a hell of a. You can see these are Waianae volcanics over here, flows and stuff like that. They almost look like they're sort of ashy, but I can't tell from here. Always raining up here, always. All right, Kauai. Kauai is thought to be one giant shield volcano. Although, as I will explain in a little bit, that has continuously been under suspicion for a while. And there are some evidence to point that might be the case, but we don't know. And a lot of it has to do with structural maps and gravity, gravity readings and stuff like that. But one thing you can tell is there's a long straight ridge right in here. This side of the island is down about 3,000 feet lower than this whole area. Why? There's a very large shield right in here that's post-erosional, rejuvenated stage. There's rejuvenated volcanism all over this area, and especially down in here. This is what is thought to be the caldera, but yet it is filled with very thick, putty-like lava flows that are just created its own swamp up here. This is one of the most resistant areas of the island. You have a huge, this is called the Grand Canyon of the Pacific right here. This canyon almost follows like a fault right in here too, and it seems it's almost as if that this part of the island in relation to this downdropped, and it almost downdropped again here. So in other words, once this fault happened, nothing has been able to get over here from these newer lava flows. So this has been relatively untouched for like 3 million years. So but yet because it's so dry, it's preserved a lot of its original shape. So it's definitely, Kauai is an enigma, and there's rejuvenated volcanism here. This is a ridge of the original stuff. It's a very interesting volcano. So Kauai, it's in either rejuvenation, dormancy, or extinction. Probably more rejuvenating dormancy, just considering the ages. It's about 5,800 feet high. That's somewhere over here. You can drive out to here. Anyway, it gets cold enough up here, right? People have seen frost. They have written their names in frost up in here, so this gets very cold. Some of the best waves in the world are found on this island. Just a lot of very, very cool stuff to go see. It was probably began its life almost 6 million years ago, but we'll just say 595, probably above sea level by 5.6. Its last known eruption consists of rejuvenated lavas, and the eruptive events are, right now, they're greater than 150,000 years. So, this is the most likely area of the last eruptions. I could not put a single cone or anything like that, but we get our youngest ages from this sort of lava area, this field down in here. And again, you don't find them coming right up here in the caldera. This is the Lihue Basin. This one is a fairly large one. I don't remember the exact date on this, but this is a rejuvenated that kind of filled up this area right in here. As opposed to being super explosive and phreatic, this one had a tendency to be fairly quiet for reasons I don't understand. Then again, I've never really looked at it. There's also a possibility that the one up here could be one of the youngest too. There's one right here near the Kilauea Lighthouse. That is suspect to be quite young. So this is Kauai. And again, eruptive dates, they're all over the place. So we know that it was pretty much going until about 500,000 years ago, fairly active. But then it slowed down, and like I said, there's a possibility of as recent as 150,000 years. This is the Kauai geologic map. This is what we think the caldera. This is the area of the caldera, and again, it should not be resistant. Usually, they tend to have a tendency to be gouged out, like every other one that we've seen. Haleakala, West Maui, Molokai, Oahu, Waianae. They're all gouged out. Why this is filled with just these incredibly resistant lavas is unusual. Main shield stage lavas here, anything in green. You have a couple of resistant areas here and here. And then, of course, the pink is rejuvenated volcanism. This is sort of I forget, this stage is sort of a post shield or a late main shield, but you got a couple of these areas here. These dark areas, these are cones, or these are what we would consider the sources of some of the rejuvenated volcanics. Again, this big one right here kind of made all this, so this is a very unusual one. And we know from wells that these go down, like 800-900 feet, so they're fairly deep. The amount of rejuvenated volcanism. It is entirely possible that this could have been a bay, or this could have been a bay kind of like Kaneohe that we see now, and it just filled up because of this massive post rejuvenated stage eruption. You have some residuals of the Kauai main shield stage, and we see that we have dikes in these, and so these dikes help us sort of give us an idea of the orientation of the dikes. Have a tendency to go parallel to the elongation of the volcano, meaning that this would be the direction of the main shield, the shape of it. And so these have a tendency to go this way all the way through. So that's why we base the idea that the Kauai volcano was probably a southwest northeast trending volcano. But then we have this problem: 2 shields or 1. So again, structurally, we have faults in here that are they're fairly bizarre. You got one here, this one down dropped, and then you've got one here and here, and again another down dropped area. And if you look at the contours, it's almost as if there's one here, a center here, and then a chunk that just down drops here. So what is really going on? And then let's not forget this one right here. As I said, it is almost as if you have a series of steps somewhere in here that dropped this whole area relative to this, and then you have another area that dropped right here. So did something get stretched? It's very strange. But in any case, Kauai offers up a very challenging scenario to try to figure out the true nature of the volcano. Was it one? I mean, and was it bigger? I mean, was the caldera out in here somewhere? I mean, it's just a very odd. And again, this is sort of bringing in my idea that maybe this was a bay somewhere in here, and this was filled up. It's a very, very, very interesting volcano, and every time they do structural work on this, they have a tendency to get more confused. I guess would be the word. Keep finding more weird stuff under there, and so I don't know. It's like I said, it's a unique volcano in the sense that structurally it's kind of a mess. And this is the Kauai alkali silica diagram. And the Kauai alkali silica diagram shows a wide variation of volcanics. You have, again, our Kilauea and Mauna Loa tholeiites right here. Of course, we have our deeper the Olakole and the Nepali members are what we would more or less consider, our main shield stage. And yes, they sort of hang out right here in the main shield stage. This right here, the Kaloa, is you would consider those more rejuvenated stage. The Makawai, some of these basalts here would be considered post-shield stage, I guess, or caldera filling stage. I think the Olicoles, yeah, that's some of these are later shield or post-shield stage. So Kauai has the whole gist of it. And again, we go right back once we get into the upper level, the Kaloa, we get into rejuvenated volcanism, and the geochemistry shows the perfect evolution that it kind of goes whoop, boom, right over here. And and these can be all over the place. But we have a large amount of uh, rejuvenated stage volcanism. Now, this unfortunately, this map is only done once. So I've got to use it twice. I'm going to come back to it when I just do Ni'ihau in a few minutes here. But this kind of shows you the Kauai, Ni'ihau, and hold on. Apologies, I noticed I had a spelling error up here, so I was able to grab it and fix it. In any case, so you have the Kauai Ni'ihau volcanoes plotted here on age versus age versus number of samples and times. So what we have here is we have Hawaii. Ni'ihau, I must explain, has very little, does not have a lot of samples from it because it's very tough. I'll go into why in a minute, but it's not easy to obtain a lot of samples. We do have two sets right here though that really show the story quite well, but we're going to focus on Kauai right now. So here's the main shield building stage right up here. It starts around 6, comes right down through here, and then has almost a 2 million year shield stage. Then you got some post shield and caldera filling stuff, and then you go into the Koloa volcanics, and this is rejuvenated volcanism, and that goes all the way down to possibly within 100,000 years of today. So classic Hawaiian volcanism, shield stage, caldera, post shield, and then a very long history of rejuvenated volcanism. And that is like a classic Hawaiian volcanism, which that's why I look at Oahu, and it's coal out like half the age, and yeah, it's got a nice long trend. I think it has more to go. I mean, look how long this is going, and this island is still fairly good size. So there's a lot of weight to be taken off. So which means there could be more volcanism in the future. All right, so this is the sort of a simplified geologic map. Again, we have our shield stage right here. Excuse me. Excuse me. All right. Shield stage volcanism here. Caldera here. These are showing our places where they took samples for shield tholiites right here. Got your post shield tholiite taken up in here, post shield alkalic up in here, which is classic post shield, and then Koloa, which is rejuvenated, and this sort of gives you the idea of the coverage. So as a rule, the center to the northwest is the oldest part, it's the most resistant part, and it's made of shield and post shield stuff. The eastern third of it is mostly rejuvenated volcanism, and you have areas of detrital debris and sediments that have been shut off, and you have a few resistant ridges. But for the most part, this area of the island has been more or less eroded. Most likely the area has been, this is the rainy side, so it just takes more moisture, hence heavier erosion. This side is drier. The lavas are more resistant, so that's why you have a much higher relief here. And again, the lack of rain. You have a rain shadow that basically starts right in here. The rain does not, it ponds about here, and you have some very resistant lows. But once you get over here, not a lot of rain. Very dry. It's like a desert over here. So this is Kauai southeast side. This picture is taken right down in here. I think it's right here, actually. My coworker and I went down, and we had to do this job in this valley down in here, and it's private. The whole thing is private. I mean, you can just tell it's gigantic. This is 3 miles away, and this whole chunk of Kauai is just basically owned by one person with a little shack down here. It was crazy. All we had to do was go down and drill a hole. It was like it was awesome. And then so right here you have the the sediments being shed off of the shield. This is the old shield right here. This is, you know, shield stage volcanics occupying. There's a valley that, you know, basically there's a bay that's been cut into here and filled with sediment, and then you have a little beach right down here. And then there's a road that comes over a bridge that's up behind me. It's just absolutely crazy, just one-way road, but an amazing place to see. This Angela. I hope she's not mad I'm using her picture. Sorry, Angela, but it was a good picture. She and I were on that job that I just showed you. This is her and I walking out to the one of the beaches out here. I can't think of the name right off the top of my head, and I'm going to shoot myself if I can't come up with it. In any place in the Poly Coast, you park at the end, and then you can walk 11 miles along this coastline, and you can do a 2-mile one that takes you to the first beach. And you know, once you go past the first beach, it just gets nuts. I made it to mile 6.8. We got rained out, and none of us wanted to do mile 7, which is considered one of the hairiest hikes you will ever do. Just imagine being along this up here, and there is only about 3 feet wide, and it's dry. There's no trees or anything, and you just, I mean, I guess officially no one's been declared killed out there, but people have disappeared. And that mile 7 is nuts. They just, when they say do it, you don't even look, you just go. And none of us, we got rained on horribly. We did like something like 7 or 8 miles the first day, and we were just pounded, and it rained, and it was miserable, and so we just ended up backtracking. But not this day. She and I got ourselves into our own stretch of trouble when we didn't bring enough water, and we risked getting leptospirosis and drinking out of the river, which I don't ever highly recommend, but I don't know, maybe it's an old wives' tale, because we chugged some water and we're expecting to get very sick, and we never did. So anyways, this is us not prepared for a hike. North Shore of Kauai, one of the most beautiful places you will ever see. This what I was talking about, those cliffs you hike along are back over here. This is a surf spot called Tunnels. Absolutely as heavy as you get for a wave. It's backdoor on a reef that closes out right down here. Then that's called Jaws, and that has claimed the lives of people. I surfed it when I was a much younger man. Actually broke my friend's board out there. It didn't break all the way, but it had a big flex in it. Not sure if I ever told him. Sorry, Ty. But the wave fires along here, and then it ends up at this place called the Jaws, and you need to get out. And it doesn't stop. It doesn't let up. It just is a freight train till you get here. So you have to like sort of punch out. And when you paddle, come out over here and come around. But when you go back, you can just go across the reef. And then here's the reason why they call it tunnels, because there's underwater caves. This drops off to like, I don't know, something like 50 feet or something. And there's like holes that go through this reef. You can go in on, divers just love it. This is another break over here. I'm not going to point it out. You can find it for yourself. Called Cannons. And Cannons is, for every sense of the word, amazingly. It's just a heavy. I've never surfed it. Because it wasn't breaking when I've been over there. But I've talked to plenty of people that will tell you Cannons dishes out dirty lickings like there's no tomorrow. And then there's a beautiful beach in here. And yeah, this is the North Shore of Kauai. It's beautiful. You've got the main shield building basalts here, and then you come over to the more the eastern side where the whole area is kind of down dropped, just 5,000-foot mountains, and then everything sort of wears away because again the rain and the trades are blowing against it, going left to right, and as you get over here, the drier it gets. So little by little, the rain shadow is working its way west, you could say. Ni'ihau, the Forbidden Island. So Ni'ihau is an island that you can't go to it, you can't visit it, you can't even go on it. It's owned by the Robinson family of Kauai. Hawaiian is spoken there. It's official language. It's left very old school, and the culture is alive and thriving. And hooray for them. They've made it so that it cannot be, everything, like, it is untouched. So if you ever got a chance to go there, have a lot of respect and consider yourself very lucky. So Kauai is the remnant of a much larger shield. You can see the shield right here. You can see the flats, as I call them, of sediments and coral reef growth and some late stage post erosion, post rejuvenated lava flows. But you can see the tip of the shield, and of course, you know, it doesn't take a lot of imagination to see it continued this way. And this is just the very top of what's left of it. It must have been much higher, lifted out of the water, but this is just, you know, basically its last gasp before it decides to retreat to the sea. You got some cinder cones here, and then some cinder cones here, and you have evidence of some post erosional flows. There's like a brackish lake here of some sort of pond. Again, this is a very dry island, so there just isn't really a lot of water here, and so life is, you know, not a lot of trees, and everything's fairly well exposed. So, Ni'ihau, rejuvenation, dormancy, probably extinction, probably a little both, don't know yet. About 1,200 foot at the top. Age probably began life about 6.5 million years ago, was up by about 6, maybe 6.3. Last known eruption was rejuvenated lavas, and it's, you know, there's a cinder cone here, or tuff cone, cinder cone here, and one down here. And the eruptive events are probably greater than 350,000 years. I put, you know, around 500,000, somewhere between these two. And our suspects are here and here. Those are the places I mean, it's kind of a coincidence that they're on opposite ends, but those appear to be the youngest. So that's my work. That's what my claim. I'm sticking to it. This is the geologic map of Ni'ihau. You can see a much larger shield beneath it. Now you can start to see, it may even, I mean, this almost tells me there's two shields, one this way, one this way. Very interesting. I've never noticed that before. Anyway, so yeah, Ni'ihau rests on a much larger shield. We use the dikes to orient ourselves with how the original island probably looked, and of course they go southwest, northeast, east-northeast rather, west-southwest. This is the shield building stage right here. Everything else is either alluvium or it is post shield or rejuvenated. So yeah. Kauai went through, I mean, Ni'ihau went through its shield building stage, went quiet for a fairly long period of time, and then produced rejuvenated volcanism. So, and anything that's in here, we have a lot of alluvium that's calcareous. With the trade winds blowing like this, low, broad, flat islands will have a tendency to have that dust blow everything in. So you end up actually creating a, you know, almost like it's aeolian, like a dune field that becomes hard and calcareous. And then you have flows that sometimes, you know, later flows that will go over it. And as I said, I felt that the latest flows, in my opinion, are maybe here and here. Hard to say. Could be in here, but these don't look nearly as fresh. I mean, this one still retains its shape, so I'm saying there. This is the alkali silica diagram of Ni'ihau. Ni'ihau is, you know, not too much of a surprise here. You have your shield right here, Mauna Loa, Kilauea. It's right on par where it should be. And then you get into post shields and rejuvenated, and of course they go into the contaminated alkalic, and then they go into an undersaturated, silica undersaturated area. So most likely you got your shields, you got maybe a little post shield at volcanism, and then of course you have rejuvenated volcanism here. And that's, you know, a very normal trend. It did not go this way. We don't have anything weird up here. Or if there was, it's all been removed by erosion. And the age, as we said, about 6.5. You know, probably a little bit younger than that. You have the shield building stage of Ni'ihau right here. Then you have a very large gap of almost 2 million years and then you get into your rejuvenated stage, post-shield and rejuvenated stage volcanism. And that has been going on for almost another 2 million years. So you have Kauai's, Ni'ihau is interesting in that you have such a huge gap in time before it kicks up again. Whereas in Kauai, and that's interesting because Kauai is right here and you don't see that gap, not nearly like you do here. So two very different volcanoes for sure. And this is Ni'ihau looking south, southeast. This is obviously a north swell in the wintertime. Jesus, I look at that and I guarantee you there's some good rideable ways. Look at this beach, just little bays and beaches and probably a whole bunch of fun ways. You got a big center cone out here to dive at. This is sort of the flat, the plains of calcareous flats, and then you have the main shield. You don't get a cliff like this unless you had something bashing up against it at one point. So my guess is that this was submerged at one point and then the waves were just bashing up against this, or this has slowly been built out, and at some point the wave this hadn't been quite as extensive and the waves were up against this. Hard to say, but this cliff is abrupt enough to tell me that at one point the ocean was banging against it. So you can see another beach down here. Oahu is this way, Kauai is over here. Again, notice no population really at all. Just a very peaceful, just nothing. Looks like somebody's burning something there. And there's Bella. Well, that is it. That is it for this lecture series. I want to thank anybody that took the time to watch this. It is a labor of love. I enjoy doing it. And I hope that everybody has a great start to the week. And aloha.